In this session, we're going to be looking at the core components of languages, what's often referred to as Turing completeness. That is, the structures within the language that allow you to write any program. We're going to be using the JavaScript language, and the reason for that is that with it, we need a zero configuration environment. All you really need is a browser. Every machine ships from the manufacturer with a browser. It is also the most widely used language and has the richest ecosystem when it comes to libraries. It is also a language that is used in the widest number of platforms. It can be used client side in the browser, it can be used server side, it can be used in devices. It is a tremendous breadth of coverage when it comes to this language and its ecosystem. And because of it, the set of tools that you will use here will serve you in many different contexts. Now, more succinctly, we're going to be looking at the following. We're going to be looking at variables, arrays, conditional statements, loops, and functions. And these can be pretty abstract terms. So let's try to ground them to things that we use every day, our everyday physical world. When we think of variables, oftentimes the example that it's given is a bucket, something that we can hold things in. And the things that we hold can be quite varied, right? We could hold a mop, we can hold blueberries, fruit, beer, fish, a number of things. And the idea here is that it is a container for multiple things. When we talk about variables in the language, we will do the same. It'll be a container to hold many different types of data. Now, this idea, of course, is not just contained to buckets, but it extends to containers. And in fact, the world is arranged to move goods in terms of containers. And this is something that if you go to a large port in any big city in the world, you will see big, tremendous stacks, and they're moved around the world with ships, with trains, and with trucks. Now, the next item that we had in the list is that of arrays. We structure our information around lists. We structure our data around collections. And so this is something that is quite useful. And it's useful to think that ultimately what we're doing is we're creating these representations so that we can think about them, so that we can act on the members of this collection, on the items of this list. The next one there was conditional statements. And there are many things in our physical world that operate based on conditions. One of the easiest examples is that of traffic lights. If you have a red, you stop. If you have a green, you go. And it is not just these physical devices that are man-made, but there's many other things in our lives. And this is one of the things that I want to encourage you to think about. Look around your physical world and try to do a mapping of these concepts that you're seeing in the classroom and see how we use them and how do we architect or plan our lives around them. The example I'm giving you here is that if you have rain, a condition might be that is when you use your umbrella. Now, the last item in the loop was that of loops, things that repeat. And once again, in our physical world, there are many things that repeat. If you think about the phases of the moon, if you think about the rotation of the earth, if you think about even a punishment on a classroom, on a classboard, you can see there the repetition taking place. And all of these together come to represent or be able to model pretty complex behavior. In fact, Turing completeness refers to that out of these components, we can write any program we want. And that is, once again, the foundation upon which the richness of software, which has grown up or which has evolved to support every aspect of our lives, is founded on. The combinations of this can be seen in things like a calendar. Days of the week repeat every 7 days. We have calendar months that repeat every year. And we have a number of actions that can be taken depending on what event is taking place. The most common example, of course, is a clock, where a second the second hand moves through 60 values every minute. And depending on where you are within that movement, you might have to take additional actions. The minute hand moves around from 1 to 12, and the hour hand takes actions based on these events. So these are things that we've seen in our physical world. And all I want to do here is to emphasize to you that a lot of these constructs are the same ideas and concepts that we're dealing with when we talk about computational thinking and the core components of languages. Now, that's a lot of words. Let's go ahead and move to the keyboard and write some code. To get started, open up your Chrome browser. Once you do, navigate through the menus as shown here. Open up the menu, go to More Tools, and then select Developer Tools. Now, at times these move about, and if you cannot find it, do a Google search to try to see where Developer Tools is within the menu. The other thing to note as well is that there are some shortcuts. As you can see there, for the Mac, it's Command plus Option plus I. For the PC, it's Control Shift plus I. These change from time to time as well. So if they do not function, you can either navigate through the menus or you can look up the new shortcut. So let's go ahead and move to the browser. I'm going to go ahead and move to Chrome. And I'm going to do what I just showed, which is move to More Tools. And the rest of my menu moves off of the window, but I am selecting Developer Tools. And what you see here is the interactive interpreter for JavaScript within the browser. And so I can enter commands directly here and have them evaluated. So if I entered 5 plus 8, you can see there that I have 13. So the very first thing that we're going to do is we're going to create a variable, and we're going to create the variable of name, and then I will assign to it my name, as you can see there. And now I can recall the value whenever I need it, and I can get that value back. Now, an important thing to note is that the variables in the language itself is case sensitive, which means that if you enter name with in uppercase, see name, and hit return, you will see there that name is not defined. And that is because it does not exist. It differentiates between lowercase and uppercase. Now you can also evaluate expressions and assign them to a variable. Let's go ahead and create a new variable called result. And in this case, we're going to enter the result, or we're going to assign the result of the following addition. And now if we took a look at result, you can see there that the value is what we expect. You can also assign new expressions that include variables within the expression. And we can do that here. Let me go ahead and create a new variable and call it result. And we will assign to it result plus 100. Now let's go ahead and take a look at new result. Let me see. Oh, it's because I'm not typing the right keys. And you can see there that we now have 109. Next, let's take a look at arrays. These are lists, as we mentioned. And let's go ahead and create an example. I'm going to create a list, and I'm going to make a list of numbers. And let's make those numbers 10, 11, 12, 13, and 14. Now, one of the common things that we want to do with lists is that we want to access the list positions or the item positions within the list. And the way we do that is by using square brackets and listing the position. Now, the thing you should know is that lists and arrays are zero based, which means that the first position, in this case the 10, is 0. And the last one, which in this case is 14, would be the fourth position within that list. A quick comment is that on the language that we're using is that JavaScript has no types, which means that let me go ahead and call this new list, could also create an array of letters in the same fashion. So let's make a short one here. ABC. Close the array, and the same functionality that we had before we would have with this list of letters. So let's go ahead and access that second position, and you can see there that we get B back. As it turns out, lists, arrays, collections are something that we use frequently. They are very useful to organize our work, and so gaining some familiarity with the constructs and how to use them is pretty important. So make sure you practice this a bit so that you can start to use data effectively within this platform. Next, let's take a look at conditional statements. But before we do that, let's take a look at comparisons. Let's say we wanted to make a comparison between 25, and let's say we were saying 25 is greater than 12. That would be true. If we did the same thing but wrote 99, that would evaluate to false. And so we can enter if else statements within the language to be able to make decisions based on the value of variables or expressions we are evaluating. A simple one to consider is one where we're making a decision based on age. So let's create a variable of age and let's assign it to 18. And then we can write a condition that asks the question, is age greater than 18? And if that is true, we can evaluate what comes between the curly braces, else we do the second statement. So let's go ahead here and simply write out to the console. So we will write console.log and we will say greater. Else, let's go ahead and say lesser or lower. Console.log and we'll say less. Now let's go ahead and run that. And as you can see there, we did not get, oh no, there it is. It is actually less. And the reason for that is because although we have a 18, the question we're asking is age greater than 18? Now, if we wanted to make it match, we could simply update this to be greater than or equal. And if we ran this, we would get the greater statement. Is it the same or equal? And so we match the first condition. Otherwise, we match the second one. Now, the last thing we want to take a look at is loops, things that repeat. And in order to do that, we're going to create a new variable, counter. This is going to keep track of how many times we have looped. And then we're going to write a while loop. And this loop is going to have a condition. This is the condition upon which the loop will stop. If we do not get this condition right, and many of you, the first time you do it, might get it wrong, this will go into what's called an infinite loop, and it'll run forever. However, our goal here is to stop at 10. And so our condition is as long as the counter is less than 10, then we will execute what is between the curly braces. So let's go ahead and write to the console here simply the value of the counter. So we will enter counter, and then we will increase the value of the counter. And we can do that by adding to counter a value. And in this case, we're going to increase by 1 on each loop, on each iteration. So let's go ahead and run that. And you can see there that we went all the way from 0 to 10. So that should make you feel pretty powerful. This is one of the things that computers can do very well: repeat, automate certain things in a very exciting way. I've been writing code for a long time, yet it is still fun to be able to do this demonstrations of the capability. Now let's go ahead and go back to the slides. And let's move over to the next slide. And it is now your turn, active learning. So open up your browser. If you haven't done already, open up the console. Make sure you start off with Hello World. This is the simplest possible case. I'm going to go ahead and clear my console here. Let me make sure I am back. And I'm going to clear, and console.log is the hello world. Make sure you can do this first before you try anything more complicated. This will give you some confidence that things are working. And as you can see there, we got hello world back. Write your hello world to get started. Then write a loop that prints the numbers from 1 to 1,000. Then write a loop that prints the multiples of 5 from it in the range of 1 to 100. Go ahead and enjoy. Writing code is a lot of fun. Great, so I hope you enjoyed that exercise. Now let's go ahead and move forward. And before we jump into the next section, let's go ahead and talk a little bit about functions. Functions is a great organizational approach when it comes to computation. Once you've figured out how to do something, often you want to package it in a way that you can use it and others potentially, and it cleans up your code and makes for a system that is a lot more usable. And so let's go ahead and move to our browser, and let's go ahead and write a quick function. And in this case, we're going to write, just like I showed on the slides, a function to add two numbers. And I'm going to go ahead and simply create an internal variable here called result. And result is simply going to be assigned the value of a plus b. And then we're going to return the result. So that is our function definition that now exists within the system. And if we wanted to add two numbers, we can go ahead and pass those in. And we should get 5 back. And so this turns out to be a great way, as I mentioned, to organize your code. Once you get a part working where you're comfortable with it, you can put it into a function, and from there on, you can simply make that function call. And this is something that we're going to be doing within our exercises or our next set of exercises. Next, we're going to be using a number of functions that we wrote for you. And in these functions, we're going to be performing many of the same exercises that we did when we were using a declarative model to construct elements within the page. So let's start off by downloading those materials. If we navigate to the browser and to the workshop materials and we click on Tuesday, we can download Ball. This is a zip file that I will download to my desktop. And then once that file is here, I will go ahead and expand it. And I'm going to show you the contents. Within it, you should have ball.html, ball.js, and magic.js. Within these files, we have written functions that will perform, once again, a lot of the same things that we did by hand in the declarative model that we use within the first lesson in this series. So I'm going to go ahead and move now into the browser. And I'm going to go ahead and select my blank tab that I've been using up until now. And the next thing that I'm going to do is that I'm going to drag and drop ball.html. As I mentioned, this has all of those functions that we have predefined for you. And now I'm going to go ahead and open up my developer tools. Again, if you do not have them open, you can find them by navigating through the menu, more tools, and then choosing developer tools. In this case, I'm going to go ahead and show you some of the functions that we've written. The very first one is one that creates a ball. Remember, we created a ball using a div tag on an HTML document. We're doing the exact same thing, except we're now doing it programmatically. And so we have written a function called create that will create that ball. And I'm going to go ahead and make this smaller so we can see where that ball shows up on the page. So you can see there, we have a new ball. Now that we have that ball, we can manipulate this ball programmatically. There are a number of functions that allow us to do that. The very first one is called size. And within this function, we can give it the ball that we're working with, and then the dimensions that we want to set for that ball. This corresponds to the height and width attributes within the div tag, if you remember when we did that. And I'm going to make a pretty big ball here. I'm going to set 400 height and width, and you can see there that we have it on the screen. Now, another of the functions that we have are functions that allow you to change the color. And so it follows a similar function signature. Here I'm going to tell it which ball to change. We could have many. And next I'm going to enter the value for the color that I'm going to assign. And these values are set in RGB, red, green, blue. And each of them had an intensity from 0 to 255. So in this case, I'm going to use 0 for red, 255 for green, and then 0 for blue. So as you can see there, we have pure green on the page. And if I change this to 255 for red, we should have a pure red ball. And yes, we do. Now you can also move the ball with the functions we have given you. Again, you specify which ball, and then you enter some dimensions. And in this case, I'm going to move it horizontally by 100, and then I'm going to move it up by 200. Remember, in the coordinate systems, for graphical systems, positive is down. So in this case, I'm actually going to go up 200. And you can see there that that was moved, and I could move it yet again by simply repeating the instruction. And if I did it yet again, it's gone off the page. Now, if I simply change the sign here, this will start to move down. And let me go ahead and start to move it over. And you can see that coming back. Another thing that you might want to do is you might want to randomly assign the color. So we have given you a function to do that. And in this case, the argument that it takes, it's only ball, and then it will randomly assign a color. So let's go ahead and do that. And you can see there how it moves through some colors and then it chooses a random color. Let's try it again. And you can see there that we have once again assigned a random color. Now, if we go back to our slides and we move through the instructions, the demonstrations that we just did, you can see there that there's a longer list of all the functions that you can use. We're also giving you one for z-index, and you can even move the ball as shown here. Now, the next thing that I want you to do is to practice what you just saw. Create a ball, change the color of the ball, change the size of the ball, and that should say off, not or the ball. Change the position of the ball, and try to replicate some of what I have just done. Next, we're going to create these balls. Instead of typing each instruction one at a time, we're going to create them using a loop. So let's go ahead and move back to the console. And I'm going to go ahead and clear my workspace here. And I'm going to start off by declaring a counter. Well, I'm going to declare it and assign it, and I'll call it counter. And this will keep track of the times that we have iterated in the loop, the number of times we've run through the loop. And before I execute that instructions, let me go ahead and reload the page just to get rid of the shapes that I have. So I've created and assigned a value to counter. Next, I'm going to write the while loop. And the instruction is going to be the following. As long as the counter is less than 10, let me go ahead and format this a little. Then I'm going to execute what is within the curly braces. And inside of the curly braces, we're going to call the create function that creates a ball. And then we're simply going to, and I hit a return. And this is a good example of the type of error that you might make. And the reason you don't see anything is because I've created an infinite loop, and this will not work at all. So I'm going to go ahead and reload the page here. And as you can see, the page is stuck. And the reason for that is that it's trying to create all of these balls and it is working so hard, it can't even reload the page. If you do that, don't worry, reload the page. And if it happens to get stuck, you can just shut down the browser and start over. Okay, now that the page has reloaded, I'm going to go ahead and paste the code that I had before, except note that now I have a counter that is increasing on each iteration. The ++ is a shortcut. We can also write it in long form the way we did before. And so I'm now going to try to create 10 balls. And I have an error, and the reason for that is that when I reloaded the page, I actually had to shut down the tab because it could not recover from the error. I'm going to move the ball code once again onto the page. And now I'm going to open up Developer Tools. I'm going to go ahead and paste my instruction, and I'll be explicit here. Counter +1 on each iteration. And now I'll hit return, and as you can see there, we have our 10 balls. Now, if I increase the counter here, I can do a lot more. And here is where it starts to get fun. You can simply see the efficiency. If we were to write those instructions by hand in the way we did when we used tags on the HTML document, that would be very painful to do. If we were to type the instructions one by one, we could do it quicker, and we can certainly rerun it every single time. But if we write a loop, we can do so in a much, much faster way. It is also a lot of fun, and you can start to see here some of the graphic possibilities. If you try to do too many of these, your browser will get stuck, but you can have some fun in trying to push the limits of how many of these you can do. So now let's go back to the slides, and it is now your turn. Try to create 1 or 2 or 5, and then scale it up. Go up to 100, go up to 1,000. And as I mentioned, play with the browser a bit and see how many you can create before the browser starts to get stuck. Once you're done with the exercise, you'll be able to appreciate the humor of programmer humor, where you can see here, as in the traditional punishment that you get in class, where you have to repeat some line over and over, 100 times, say, like this one, I will not throw paper airplanes in class. In this case, the kid has written a loop that says this will write out the 500 times that the punishment would have taken. And you can see there, the response from the teacher. Now, to close out the section where we're working with balls here, we will do an assignment, or we will do an exercise where we will be able to create those balls and assign them to a list. Oftentimes, it is very useful to be able to do that, because once you have them in a list, then you can perform some other operation on it. So I'm going to go ahead and select the code here and move back. And I'm going to take the first block. I'm going to move back to the browser, and I'm going to go ahead and reload the page just to clear out what we've done before. And now I'm going to bring back the console, and I'm going to go ahead and execute. And as you can see there, we have created a number of balls. In this case, 4, I believe, is what we did. And now we're going to act upon that list. And the way we do that is we simply iterate, or we move through all of the components of that list. We first get the length of the list here on the second line, and then we move through the list and we use the color random function that is available to you. I'm going to go ahead and make it a little bit bigger so you can see. And you can see there that the very first line is a counter. The second one gets the length of that list. This is a feature of the language that gives you the length of the list. Then we have our condition, which will run as long as it's shorter than the list. And we get each of those balls one at a time. And then we use the color random function to be able to change the color. And we increase the counter so that we do not get an infinite loop. So I'm going to go ahead and run that code. I'll run it here off the screen so you can see the changes to the balls that we have on the browser. And so as you can see there, the balls change color, and we were able to do that on the list that we have. So if you imagine you had a long collection of graphic objects that you wanted to move through some transformations, you can do this in a much more efficient manner than doing it instruction per instruction. In the next section, we're going to be working with data, quite a bit of data, over 4,000 entries, as you can see. And if you're wondering what those values are, they're colors in hexadecimal. You can see here some of the common colors represented in some of the hex values below it. Now, there's a lot more that can be represented just like RGB. And if you're curious and want to play a little bit with the colors and the codes, you can do a search on Google for color picker, and you will find ones like the one I'm showing you here, and you can navigate and you can use the pickers and the graphical spectrum to be able to choose the color or the hex value that you're looking for. Now, what we're going to be doing here is we're going to be giving you a large collection of hex values of colors, and it's really just a very long list. This is an array of values for a painting that we are giving you. We're not telling you yet what it is. And in order to access each of the elements in this list, just like before, we would use the square brackets notation as you see there before or below the ball comment. We've also given you an X and a Y position so that you can place the ball in the right X and Y and give it the color that is part also of that specific ball. And if you render them all on a loop, you will be able to recreate the painting. And so here is a good exercise on data where you're giving a large collection of hexadecimal values plus position, and your goal is to be able to place all of those on the screen. And so I'm going to get you started here with a little bit of the basics. And in order to do that, we need to download a zip that has this data and the functions that you will need. So I'm going to navigate here to my Chrome browser, and I'm going to go to the course materials. So this is the home, and I'm clicking on Tuesday, and we're going to download Painting 1. So I'm going to right click, save link as. I'm going to put it on my desktop. I'm then going to unzip the file, and I'll show you the contents in a minute. And here are the contents. I have ball.html, ball.js, and magic.js. I'm now going to move back to my tab where I have been working, and I'm going to drag and drop that ball file, as you can see there. I'm then going to access that data within the console. If you remember in the slide that I just showed you, which is this one, I showed you there that we can get access to the array. This is the long list of data through the variable called data. So I'm going to move back, and I'm going to enter here data.length. And this is a property of the language that allows us to get the length of this list. And as you can see there, it is 4,293. And if I wanted to access any one element, I will do that here. You'll see there that this is the 0th element at X, Y in the specific color. So if we wanted to I'm going to simply enter that so I can see it. And if we wanted to go ahead and write that ball for this 0th element, we would use the following function. So I'm going to cut and paste here. And I'm going to move back to, well, let me make sure I have both the browser and the console. And in this case, I'm going to paste here the create. However, since I have not defined ball, this will not work. So let me do that. And it created a ball, but it did not create it at the right place. So let me restart this over just to make sure I don't lose you. So let me clean this up, and I'm going to create here ball, and I'm going to get the 0th element as I mentioned, right? And so I am going to access that, and I have assigned it to ball. And now if I look at ball has the information that we had before. And if we paste the code that I copied from the slides, you can see there that I am passing to create ball X, ball Y, and then the color for the ball. And if I enter this, you cannot see it because I believe this one is white, or it's a very faint color. Or let me go ahead and move around on the page and see if I can see something. I cannot. Let me choose one that I know will have a value. So let me look at the data for a second. Okay, I found one. Is the 400th element. So I'm going to go ahead and assign that to ball. And then I'm going to go ahead and use the create function with the ball information. And you can see there that a little circle has been placed onto the page. So your job now is to move through all of this data and place each of those balls onto the page. And as I mentioned, if you do it right, you will discover the painting that we have created data for, and it should be a fun exercise. Now, if you're curious how to save your work, you can do it in the following way. I'm going to move back to the browser. And as you can see, here are the instructions that we entered before to create the little dot, as you can see there. Now, within the files that you downloaded, there are 3 files. There is a ball.html, a ball.js, and a magic.js. If we open up ball, you'll see here that there is a section for you to save your work in. It says your work goes here. And actually, let me open it up on the Visual Studio Code editor, which is the one we have been using. I'm going to go ahead and move to that. And I'm going to drag and drop that file into here. And then I'm going to paste those instructions. I'm now going to go back to the browser, and you'll see here that I'm going to reload the page. And although we do no longer have the instructions, if we go back to the console, we no longer have the instructions on the console, yet we have the ball. And the reason we have the ball, it's because we have written it into ball.js. So once you're done, or if you want to move to the JavaScript file that is being loaded every single time into the page, you can do that as well. This will also allow you to save your files and take them home if you want. Now, if you happen to move very quickly through the recreation of the painting using the hex data that we have provided for you, you can take on the following challenge. And that is, how would you scale, rotate, translate, and skew the image that you're working with? Most of the information that you want will be inside of the magic.js. If you scroll down to the bottom of that file, and that file is challenging. It has a tremendous amount of information and a lot of things are being done there. But if you are done pretty quickly and you want to challenge yourself, go ahead and open up magic.js, and you can give a try at trying to do scaling, rotation, and translation. We have covered a great deal and we have seen a lot of examples. However, it's important to map back to where we started. We talked about variables, arrays, conditional statement, loops, and functions. And we talked about those analogs to physical world, to our everyday lives. And think about it in those terms. If you do, it is pretty accessible. It's nothing different than what you've been doing all your life. And a lot of the syntax and a lot of the tools can be challenging and can be confusing. But remember the concepts. The computational thinking is what it's important. And if you can think in terms of those, then you can execute in a way that you hadn't possibly considered before. And that is what this is all about. Those beautiful patterns, those beautiful ideas, those powerful abstractions. And in this case, those core notions that are part of every single language. It doesn't matter what language you're on, Python, C++, or many others. They're all the same. And that is what is amazingly powerful and exciting about these platforms and the potential that they give you. So with that, happy coding and goodbye.